Alright, can't handle the crazy hair anymore, so I have my official 4-inch in skull cap. So, slightly more interesting circuit, actually a much more interesting circuit. The D flip-flop. Here we have 3 cells again. The bottom cell here is simply routing our load signal from the left of cell 10 into the K input of 00. We're feeding a data input into the left of cell 00. And 00 responds as follows. If the load signal is high, meaning it's at least 32, then we take the data value and we send it out to the right. Otherwise, we take the data value from the right and recirculate it. And cell 01 is simply taking what's coming in the left and recirculating it, but also optionally sending it out to the north. So we have a simple simple D flip-flop using these 3 cells. This will be the load input, and this will be the data input. But it's analog. So, still our Arduino board, we have 2 inputs. This will be the load input, the data input, and this will be the load input, or the latch. And we can monitor the output. The output is currently 0, and changing the D line has no effect on the output. But if we open up the latch by raising this all the way, we can now set the D input and see that value reflected in the voltage output. So we can set it to, I don't know, some number, 3.09, and now we can close the latch. And now the D selection has no effect on the stored value. So we've effectively made a little sample and hold where we select a sample by raising the other value on the potentiometer. Now if I open up the latch again, whatever value I had set on that potentiometer will suddenly trickle through, 4.51, and we can latch that in, and now the D potentiometer has no effect. And now I can open the latch again. The D value will trickle through, which was 0.84, and I can set whatever value I want. Maybe I want to sample a value at exactly 1.06 or 7. I can close the latch. And now the D value again is latched inside this analog flip-flop, and changing the D input has no effect on it. So we have the same analog of a digital flip-flop, no pun intended, the same version of a digital flip-flop, but in an analog form. So we can actually load in a value from 0 to 5 volts and trap that inside the circulating pair of cells here and here by lowering the load input.